In the series of this new this distance learning program, that is geospatial modeling on watershed management. Under that, as we are having 5 lectures in this series, and the first lecture today, which I will deliver on how remote sensing and GIS can be used for watershed management. So I will give an overview of that one, and then we will progress for how the modeling approach can be used or technology being used for watershed management program. So we will see one by each day, 4 to 5 p.m. This class, but today we are late little bit. Doesn't matter. We will cover the entire syllabus. In this lecture, I am going to cover for the major for the benefits of the participants. I will start with the basics of remote sensing, GIS and GPS applications, and then in that I will give an overview of that one, how remote sensing technology, where we are stand, and then it will take it to the how land degradation status in India and watershed development programs being being executed in India, as well as the various components of watershed, how those informations we can retrieve from the remote sensing technology. And at the end, few slides I will cover on the soil erosion mapping, geospatial modeling, how we are going to do that one, and showing that is the entire content of in this lecture, that in this course what we will be going to cover. So if we see that is the a common word which is being used as a geospatial technologies, and in this 3 technologies we talk by integration. One is remote sensing, where space-borne and airborne satellites or space satellite remote sensing we talk. Then geographic information system, which used to prepare or develop a spatial database for your informations what you have collected in for the watershed. And GPS is a system provides information about the geographic locations of the place. If we see the remote sensing technology, then remote sensing and GIS are being used as a tool to prepare various thematic maps. For example, soil map, land use, land cover, geomorphology, geology, and topographical informations we can retrieve using remote sensing and GIS. That is very means that becomes a part of your to analyze your natural resources. Most important part of the remote sensing is that it provides us real-time information about various resources over a large region to generate baseline information, as well as it also helps us to get reliable information of natural resources, because we know that is the you are getting the remote sensing satellites on every month, or you are getting weekly, monthly, or every years you can take. So you can make update information about land use, land cover, what changes has been taken. Some of the resources are static, not changing so fast, not dynamic so much, but land use, land cover and other informations are dynamic. So those informations we can get with remote sensing. If we see simple, just to familiarize you that how remote sensing technology works, although you may be aware of that one, but just to refresh your knowledge, if you see that is the this is the when satellites orbiting on the Earth's surface, it takes the picture, or it takes the reflectance of the Earth's surface, and it is recorded, and that reflectance is sent to the or transmitted to the ground station, that is a Earth observation system, where satellite data are received. And this satellite data is nothing but you will get a picture formed in a pixel form, that is the comprises of pixels, where of each pixels. You can say that is pixel is nothing a land area of which we get the reflectance. So X and Y position, that is the land pixel or location of the land, and of it we get the reflectance value. If we see that is the remote sensing technology is it uses electromagnetic radiations, or mainly I am talking here the optical remote sensing satellite data. And optical remote sensing satellite data takes the pictures in visible and near infrared region. In visible and near infrared regions, if you see the electromagnetic radiation, in this we are you may aware that visible wavelength region are blue band, green band, red band, and near infrared. And this blue, green, red are visible wavelength region, and near infrared is another wavelength region, which provides a very useful information about the vegetations and other earth resources. And third, that is we are also using in remote sensing thermal infrared band. So these bands, you can say, when satellites are providing the data in this wavelength region from visible, infrared, and thermal infrared, then these satellites are working called as a multispectral or hyperspectral remote sensing. Another remote sensing satellite data in the another wavelength region is the microwave regions. And microwave regions, that is the these satellite data are these satellites can operate in cloudy situation, or when the weather is not having sunny, or there is a rainy seasons, or when the weather is not clear or atmosphere is not clear, then we can receive the microwave remote sensing data. So here I will discuss mainly the multispectral and hyperspectral satellite data which are being used for the mapping of the resources of watershed. If we see that is, if I summarize, that is optical remote sensing data, it record the reflected radiation in the wavelength region of 0.4 to 3 micrometer. Thermal remote sensing data, which record the emitted radiation, not the reflected one. It is emitted radiation from the Earth's surface, and it operates 3 to 15 micrometer. And this emitted radiations, it is because of Earth object is having temperature, and because of its warmness, it emits the radiation in the long wavelength regions, and this is used for the sensing the temperature of the Earth object. Another is the microwave remote sensing. As I told you, this is the these satellites generally be used when the weather is cloudy or rainy, and when we are not able to obtain the satellite data from the optical remote sensing data. If I give you just to brief you that when remote sensing satellites is orbiting on the Earth surface, it takes the pictures of Earth surface or in various frame size. The frame size depends on the resolution of the sensor. This is the zone for the resolution of around 22.5 meters spatial resolution, and the satellite is orbiting at 817 kilometer above the Earth surface. And this is the schematic diagram of Indian remote sensing satellite, that is resource set and sensor list 3. And Indian remote sensing satellites having the these sensors having the four cameras, and each camera is operating in the individual bandwidth of B2, B3, B4, B5. If I say this wavelength region, B2 related to the green band, B3 is red band, B4 is infrared band, and B5 is short wave infrared band. And it records the reflectance in this wavelength region. This is the range of the wavelength region in which these cameras are sensitive, and so we call it is a sensor. So in general, what happens when the radiation is coming to the on the Earth surface? Suppose this is a tree and it is having the chlorophyll content, and so what happens then? Radiation is coming from the sun, then red radiation is absorbed by the vegetation due to chlorophyll content, and infrared is reflected. Green and infrared is reflected, whereas red is absorbed. Infrared is not absorbed, it is reflected back. So you can say that some of the radiations are absorbed. Among them, red is the prominent one, and some of the radiation is reflected by the vegetation, and infrared is among the prominent one. And this absorption and reflectance, that is this interpretation of the reflectance behaviors we use to derive the Earth object informations, to derive the Earth object information. If you see in remote sensing, we study the spectral characteristics, and I am showing here the typical reflectance characteristics of the vegetation. You can see that is because of chlorophyll content in the vegetation, this band 3 or red band radiation in red band is absorbed. That's why you are getting the low reflectance. But the infrared, that is band 4, which is get reflected in high amount, and that's why infrared it is reflected and give high reflectance, but red is absorbed. And why it is absorbed? Because of chlorophyll. And why it is reflected? Because of the structure of the plant cell. And here you are getting 2 absorption, and it is because of the water content present into the vegetation. So this reflectance characteristics, if you analyze, you are getting the picture from the satellite data. Then red and infrared radiation absorption you can characterize, that is the vegetation and vegetation condition or vegetation health. Just I show that in remote sensing technology or remote sensing data interpretation, we used to generally generate the false color composite. What do you mean by false color composite? Because as we know, that is our eyes are sensitive to the 3 spectral wavelength region: green, red, and blue. Green, red. No, it is 3 primary colors, that is blue, green, and red. So we need to project our satellite data in these wavelength, in these image plane. So you see here that is if we take the satellite data of individual bandwidth or individual camera, then it will appear as a black and white. But what we do, that is we project infrared image as a red color, red band image as a green color, and green band image as a blue color. So you see that why we do that one, because infrared our eyes cannot sense, and in infrared I told you, because it gives high vegetations, give high reflectance. So infrared is very useful for vegetation study. So what we have done, that is blue band we are not taking, blue band camera are not there. Cameras are there, green, red, and infrared. So green we project as a blue, and red we project as a green, and infrared we project as a red. That's why it's developed the false color composite. So this false color composite is where vegetation appears as a red color. As I told you, vegetation gives the highest reflectance in infrared, and if it is high reflectance value you are projecting in red color, then it will all vegetation will appear as a red color. So you can see here that is you are getting the different sets of the red color representing different vegetation type. If you see the one picture satellite image, and you can see here that is the brownish red or dark red, it is the showing the vegetation, forest vegetation cover. You are seeing the orange red, this is showing the cropland, and this is cyan color showing the false, showing your fallow land. and you see the river, which is the irregular shape and cyan color because of it gives the high reflectance in all spectral bands. So it should appear as a whitish in color, but due to moisture content in the riverbed, you are getting in cyan color. So because of moisture in soil, also fallow lands appearing in a cyan color. So different vegetation, different Earth surface feature we can see in the remote fast color composite of the satellite data, and we can map all these features. We can map forest area, crop area, we can map the fallow lands. All these features can be mapped very easily. Another terminology used in the another things in satellite data are very commonly used. That is the one is the resolution. You see that is the we get the satellite data in three type of resolution. One is called spatial resolution, where it is related with the pixel size, means how much ground area we are recording the reflectance value. So today remote sensing data are available from 1 meter to even 1 kilometer. But what does it mean? 1 meter data are very high resolution satellite data, and you will get more clarity of the Earth objects, because 1 meter by 1 meter we are getting one reflectance value. Here 30 meter by 30 meter we are getting one reflectance value. So in 30 meter, if you are getting one reflectance, so within 30 meter, if 2 or 3 objects are there, then it will give only one reflectance. So they are mixed together. We are not able to segregate in the remote sensing data. If you want to segregate the fine features, then you have to take the high resolution, high spatial resolution satellite data. So you see 1 meter, the same area, how it appears in 1 meter, it is appearing like this. 10 meter, it is appearing like this. But 30 meters, you can see those, even the linear features, the road, which is, it is not, is very clear. So this is the resolution, spatial resolution of the satellite data. Another is the spectral resolution, means how many number of spectral bands or how many cameras are there, spectral bands are there. So multispectral, generally 4 to 10 number of bands are there where we record the satellite data. But in hyperspectral, we get very close sampling of the spectral wavelength region. So here we get more 100 to more than 100 spectral bands to interpret the satellite data. And third terminology we use as a temporal resolution, means how many the satellite data visit the same place after how many days. So in general, today's satellite data are visiting the same place maybe weekly, monthly, or daily. Even some of the satellite data are visiting the same place on daily. So temporal resolution data are providing, you are able to get the satellite data of Earth pictures on day 1 to 7 days, weekly or monthly, weekly data or quarterly data you are able to get. Another, if we see that the Earth observation programs has completed, the first remote sensing satellites was launched in 1972 by NASA in USA, and India launched its first satellites in March 1988 with the resolution of 80 meter. And this satellite data Landsat MSS was also of 80 meter resolution. So you can say that when in 70 it was 80 meter resolutions, and today we have reached to even sub-meter, less than 1 meter spatial resolution satellite data are available. But and another satellites, here I am showing the 2 remote sensing satellites. One is the European Union's providing Sentinel-2A satellites, which is available freely. You can download from the internet, that is having spatial resolution of 10 meter, spectral resolution of 13 bands, and you will get the satellite data of every 5th day. And another American NASA provides the satellite data freely downloadable is the Landsat 8 satellite data, where spatial resolution is 30 meter, spectral resolution 13 bands, temporal resolutions means here is 21 days. where in Sentinel-2 data, 2A satellite data, you are having every 5th day the revisit of the same area. So these two satellite data now are available you with 10-meter and 30-meter resolution. Another data in microwave remote sensing region, which is available, is your Sentinel-1A SAR data, that is synthetic aperture radar data, which is available freely to use for the cloudy weathers and when the atmosphere is not clear. Then after this basics of the remote sensing, then I just finished, that is geographic information system. And you know, the geographic information system, we also progress a lot from DOS version to window based, and today we are having web based GIS software also through internet. Also you can compute on the web server. And this GIS is used for generating spatial information and to integrate and analyze the model these spatial information. And these are the softwares which are available on internet freely, which you can download. Another is the global positioning system, GPS. And today we are having various GPS systems, and among them most common is the GPS, which is launched by US, maintained by US, GLONASS from Russian, Galileo from Europeans, and various geospatial softwares are there. India also have geospatial software, that is your, you can say, having a GPS system for regional, to meet the regional requirement. It is Indian Regional Navigational Satellite System, IRNSS, and where we are maintaining 3 satellites in geostationary orbit and 4 satellites in geosynchronous orbit. It provides the GPS location with more than 10 meter accuracy. So this is the GPS which are available today. Indian remote sensing satellite data, if you see, India has at present maintained 13 operation satellites, and various satellite data are available in the Earth orbit, and it is providing us satellite data of various spatial resolutions from 5.8 meter in multispectral band to 1 meter in panchromatic or black and white. You can say Cartosat 2A, the latest one, Cartosat 3 that is launched in 2019, providing even the spatial resolution of 25 centimeter. So with this basic, I switch over to the main subject of our course, that is watershed management. I will give here you an overview that in this entire course, what we will going to discuss in the remaining 4 lectures. But in this watershed management, how we can use remote sensing and GIS technology. When we want to study the watershed management, then first things comes that we need to select one watershed. So and then we need to codify this watershed. So we do the codification or give the standard nomenclature. And today in India we are having digital watershed atlas, which is and also in the ISRO Bhuvan portal, you are also having the this watershed atlas, which is overlaid over the Indian region. And then we need to, for watershed management, you have to characterize the watershed. So delineate and prepare the map. Then we need to prioritize, because there are many watersheds you have delineated, but which watershed having the major serious problems, that watershed we select that one for our conservation planning. Then we go for optimal land use planning, and we after this land use planning we implement on the ground by the administrations or by the project staff. Then we need to monitor what development has taken place on the ground. Then we can do the geospatial monitoring and impact assessment of the watershed. So the last lecture we will discuss in detail the geospatial monitoring and impact assessment. And in the one lectures, we will discuss the land use planning in the watershed. And tomorrow we will discuss main on the watershed characterization. So this various component of watershed management will be discussed in this course. If we see that is the what do we mean by the watershed? So you see the watershed concept was introduced in 1920, and it was used as a water parting boundaries or water divide lines. What do we mean by watershed? Watershed, you can say, it is a land area. It is a land area which drains or contributes runoff, because it is a land area where the rains, the runoff from the entire area drains off at a single point, a common outlet. So when rain falls on the land area, part is go to infiltrated, and rest of the rainfall as a runoff, generate as a runoff, and it moves towards and it accumulated or it goes to the single drain. Watershed also you can define as a geohydrological unit draining to a common point by a system of drains. So you can say it is a geohydrological unit because the rainwater infiltration depends on the geology of the area, land use, land cover, and other earth surface features will govern the infiltration rate and generation of runoff. So you can say the watershed is an land area where the rains from the collected from the all the area, and it goes to the common area or single outlet that can be defined as a watershed. Watershed, if land area is this is one watershed. So for example, this watershed we can divide into the sub watershed based on the drainage pattern. So drainage line or drainage pattern
सर हैंग हो गया आपका ये
yes, when the area is 0.5 to 2,000 square kilometer, then it is called watershed. So based on the area of the land area of the watershed, we give the different terms. And you can say the watershed, subcatchment, catchment, basin. These are basically the watershed, and based on the size of the land area, we give the different name. Now you can see in the watershed management refers to the rational utilization of soil and land resources. So within the watershed, whatever the natural resources are there. Natural resources are soil, geology, topography, land use, land cover, and water, surface water, groundwater. All those resources of an area, its optimal utilizations or its rational utilization is required for the sustainable development of natural resources within the watershed. So that is the actual meaning of watershed management. So for that one, what we do, we create a database, a reliable database of natural resources of that watershed area, and prepare the plan for its utilization of the resources programs and projects so that we can enhance the watershed functions. Its watershed functions we can enhance, and that affect the plant, animal, and human communities. So in this land area, people are living, and villagers are living. Their fields are there. So animals and human rural development. So you can say the rural development of the peoples who are inhabited in this watershed is also addressed by this watershed management. This is the picture is shown, that is the satellite data, how we can delineate the watershed. You see that this is the one watershed is delineated, and all the rainwater means after infiltration, the rain left on the surface is known as a runoff water. So all the runoff water is coming and getting accumulated here. So, this is the water divide lines. Here the gradient is in this side, here the gradient is in this side. So water, if rain are falling here, that will go this side if it is beyond the ridge line or height of the watershed. So this is, you can say, the highest elevation, highest height of the watershed, and this divides the between. This is also known as a water divide line, and this entire land area runoff water gets moves and get accumulated at the outlet points. So we can say this is one watershed. Now, if we want to use the resources in this watershed, what are the resources? First resource is land use, land cover. Second resource is soil. What type of soil is there? Somewhere the soil is deep, somewhere it is shallow. Geomorphology means hill lands, valley land, or different type of geomorphologic features are there in this watershed, which we can utilize for its optimal use for agriculture production. Terrain information means land area where the slope is more, where the slope is less. Suppose on the ridge line, the slope is here, the slope is more, but here the slope is less, or flat, more the gentler slope. So this information we can utilize. If it is the higher slope, we cannot go for agriculture, but in the lower slopes we can go for agriculture. And drainage pattern, what kind of drainage pattern is there? These informations we require to prepare a good watershed management program. Here we can see that is in India, watershed management program are being implemented since long time, and earlier we were in 2008 central government. Before 2008, central government was implementing 3 watershed programs. One was named as a Integrated Wasteland Development Program, Water Drought Prone Area Program, Desert Development Program. 3 programs were major programs before 2008. Then Government of India integrated all 3 programs, because all the 3 programs objective were almost same. Only the area was different type of based on the rainfall and geomorphology. So they integrated as a Integrated Watershed Management Program, IWMP. And this IWMP program, again in 2015-16, in 2015, the present government has given its name, renamed as a Pradhan Mantri Krishi Sinchai Yojana. We know now it is a Watershed Development Component, WDC, Pradhan Mantri Krishi Sinchai Yojana. So every state in the country, every state is implementing the watershed development program, and it is the major program of soil and water conservation in the country. And you can say the government of India and state government together, they are implementing this program to conserve our soil from erosion and to conserve water resources and increase the productivity, agriculture productivity in the watershed. So watershed, you can say it is a administrative unit of natural resource management. As we know, that is that, you know, the district, taluka, village are the administrative unit. for administrative management of human resources. But for natural resources, for resources of soil and land, soil and water resources, land and water resources, the land management is done on the basis of watershed. That's why watershed management is a natural resource administrative unit, we can say. The main objective of watershed management is to restore ecological balance, because you know the watershed, we are conserving water. If water is flowing, then you know the nutrients is also lost, sediment, soil is also lost, and because of that our forest ecosystem or vegetation ecosystem will be degraded. So to maintain ecological balance, we need the watershed management. So watershed management, the prime objective is to restore the ecological balance and developing degraded natural resources such as soil and vegetation cover. The outcome is the prevention of soil erosion, runoff. We can prevent soil erosion, runoff, and conserve the water resources or rainwater harvesting. So these things will be important, and we can provide the fresh water or filtered water and not the sedimented water to the river system, so that our river will be also fresh water, carrying the fresh water, and there will be no sedimentation in the river or in check dam or reservoir. So that's why watershed management is very important for any country which is having the agriculture as a livelihood. In India, if you see that how much area we are getting degradation, because you know because of degradation our resources are degrading and we are not able to meet out the food grain productions. Mainly land degradation in India, if you see 70% of in India total degraded lands is 120 million hectare. This is the recent estimate. 120 million hectare is degraded lands, and out of that 70% you can say water degraded because of water erosion, 12% degraded because of wind erosion, 16% is degraded because of chemical degradation, that is your salt affected soils, 1% is degraded because of physical degradation, that comes as the compactness of the soils and other things. So total you can say our 104 million hectare of agricultural land, that is your 86% lands are getting degraded or characterized under degraded lands, and 14% of forest lands are also degraded, mainly where there is a degraded forests are there. If you see in India, why we need to study the watershed management, because India's soil erosion rate, I told you the soil erosion, degrading soil erosion, water erosion is the most important land degradation type, and 70% lands are degraded because of water erosion. And this water erosion in India rate is 16 tons per hectare per year, although the permissible rate of degradation, water erosion is only, we can permit 4.5 to 11.2 tons per hectare, depending on the depth of the soil. So you can say even our the erosion rate is very high as compared to your as compared to your permissible values. Our 29% of the eroded soils is lost permanently to the sea, and 61% of the soils are displaced one place to another place. So in the watershed, because of soil erosion, we are having degrading the lands a lot. Problems are coming, and that's why we need to have a soil and water conservation measures. How this degradation take place? If you see, mainly the water erosion is because of your surface runoff generation. What is the process is taking place? You see here that when rains comes here on the land surface, part of the water is infiltrated and go to the groundwater and absorbed by the soil, and part of the water is get transpirated or transpiration take place, or evaporation and transpiration, you can say evapotranspiration. And after that, what water left on the earth surface or land surface, that is that is known as a runoff. So you see, this is the picture of one watershed land area when, because of rain, that is in the agriculture field, which is the terraced agriculture field in hilly area. You see how the water is, runoff water is flowing from the earth surface, and they are removing the soil as well as soil nutrients. So you can say that in soil erosion, when rains drop falls on the earth surface or land surface, then the first erosion is called splash erosion, then sheet erosion, rill erosion, gully erosion, and then called it is piping or tunnel erosion. So these five types of erosion used to take place. And which are the factors affecting the erosion? That is the rainfall, how much rain is occurring, what type of soil is there, if soil is very erodible, if soil is sandy or clay, so different type of soils eroded differently, topography, what kind of slope is there, and what vegetation cover is there. You see how the field pictures of the erosion. When the top soil is removed from the rain, then you see how this is sheet erosions, when stones and you can say that fertile top land having darker color organic matter has been removed from the field. Here you can see that the sheet and rill erosion and the soil from other areas removed and get deposited, and they damage the field also, and it is there they move from the concentrated flow and forms the rill. So rill erosion, here you can see rills and gully, how they are formed on the hilly sloping lands, and here you can say that is the runoff is moving, and then it is carrying the lot of soil along with them. If we see on the satellite data how we can map this erosion features. So this is the one satellite data where this is the hill area and this is the flat land. But you see, as I told you, as the top soils when eroded, then you will get more concentration of sand and clay particles are moved out or wash out. Then surface becomes rich in sand and less in organic matter. That's why it will give high reflectance, and they appears as a more whitish, more white in color. So you see, this is the moderate erosion, and here is also you are getting whitish. So it is slight erosion, but this area having no erosion, having crop cover or vegetation cover. So slight erosion, moderate erosion, and here you see near to the hilltop, there you are getting, that is the here you are getting lot of closed gullies are there, and you can say the that is the linear features you are seeing, and these are the gullies, and lot of gullies are there, or you can say dissected land. They are the dissected lands, and we can characterize it is very severe erosion. And this is also, you say dissection is less than this one, but are you getting the gullies here? So it is severe erosion. Although this entire area is under forest, but you see, and being under forest, these lands are also getting degraded very severely. Why? Because the soil and topography. Soil is erodible. Here soils are not are sandy and silty in nature. Because of silt content, these soils get more eroded, and topography slope is very high. So slope and soil type is affecting the erosions here. But what I want to show you, that in the remote sensing satellite data, fast color composite, you can very well see that is the various erosion features, and you can map it by visual interpretation technique. Another information, when we want to study the watershed management, then another information which you want to know, that is your what type of watershed shape and size. So we call it is a morphology of the watershed. we want to go for soil survey to study what kind of soil is there. Then we can prepare a land use plan. We want to study what kind of land use is there, how much forest agricultures are there that you can do with the remote sensing data. And we can also do the hydrological survey using remote sensing data. Water bodies, streams or runoff can be studied. So if I see that is show you some examples, that is you can see here that a land use land cover map of one watershed. This is the micro watershed and high resolution satellite data. You see this red color is the forest. This is the forest, moderately dense forest. These are the fallow agricultural lands. So different land use land cover map you can prepare with the remote sensing data. Even this is the natural color composite, not the false color composite. In natural color composite, the vegetations appear as a green color, and we can also in the watershed we can see this is the green is showing the dense forest, and this is the light green is showing the cropland. So we can see the cropland, moderately dense forest, or different type of vegetations and land use we can map with the help of remote sensing data. Another another important parameter of the watershed characterization is the terrain analysis. And today digital terrain analysis are being used, and today from the remote sensing data we have generated the digital elevation model, or DEM, or today globally it is available on the freely you can download from the internet the DEM of your area. And this DEM has been generated using stereo satellite data. For example, stereo satellite data, Cartosat satellite in Indian regions we have Cartodem, and Aster also from the stereo satellite data, and SRDM from the micro remote sensing data for the entire world, generated by US. So different type of remote sensing DM are available today, which you can analyze. That in detail I will discuss tomorrow in a separate lecture, which is devoted on digital terrain analysis. You can see that digital terrain analysis from DM you can generate the 3D view of your area. So you can see this is the hill and this is the flat area, and this is the digital elevation model. And from digital elevation models we can generate the slope map also, and various other parameters. So in details tomorrow I will discuss this in detail. Another, we can utilize the remote sensing data for soil mapping. You see the remote sensing data, we can see that is the various features of geomorphology, terrain parameters, land use land cover parameters. For soil mapping, as you know, soil is the function of climate, organism, relief, parent material, and time. So these 5 factors are there, and these factors can be very well studied with the help of remote sensing data. And we can make, suppose in an area, you can see that is the I can even generate the topographic informations also. You see, I can say here lot of dissection. This is very steep slope, undulating slopes, gentle slopes. I can see here. I can also see that is the landform. These are the hilly landforms, and these are the foothills or plain landforms. I can also study the crop, land use land cover. Forest is the one cover, and cropland. These are the cropland. So I can see that is the topography, geomorphology, land use land cover. I can study with the remote sensing data, and by integration of these 3 informations, I can prepare a soil map. How we do the soil map? So first we prepare the geomorphology map. You see, this is the geomorphology map. Geomorphology is further divided, taking into account the topography. So you see the hills has been divided into on the basis of slope, and your foothills has been divided on the basis of slope, and that further can be divided on the basis of land use land cover. So you will get this much of map unit, and each map unit, then representing map units, you can take one you can collect the soil samples and you can say this soil samples will represent the entire area. Why? Because in watershed, you need a soil information. But from in soil information, where to take the soil samples, then you have to do the soil landscape analysis. And by this one, it will decide where to take the soil samples. So you do the soil landscape analysis using remote sensing data and decide that is suppose this is the one area, and in any place you can take the soil samples to characterize the soil type in this area. So we go to the field, because directly from the remote sensing we cannot get the soil data or soil informations, because you know the underneath we are getting from remote sensing the surface reflectance, but soils are subsurface information. So in profile you see the stones, but here is the soils and different layers are there, so we can study after taking the soil profile study. Another which part that is we can use the remote sensing derived input for assessing soil erosion, quantitative analysis of soil erosion. In one lecture complete, I will discuss on the erosion modeling concept, how we can do erosion modeling and how we can derive the various model input parameters. So just giving you an overview how we do the erosion risk assessment of watershed. You can say that from remote sensing data and take the toposheet or digital elevation model, and you need the meteorological data or rainfall data. If you are having remote sensing data and DM data or topo sheets, then together you can prepare the land use land core map, which I described earlier. You can prepare the soil map, which I have discussed also, that is preparing the soil landscape unit map. And you can do the terrain analysis using digital elevation model. So that also I will discuss all these things in my third day lectures, how we can derive this one, and this you can put into the GIS. Here in GIS you can integrate the erosion models. There are various erosion models are there. Using those erosion models we can integrate these informations, and meteorological data or rainfall erosivity we can integrate here, and we can prepare a soil erosion risk map of your watershed. So you will be able to know where the erosion rate is high, where the erosion rate is less or low, so that if high erosion rate area is there you can go different type of conservation planning, and if erosion is moderate, then your soil and water conservation planning will be different. So for soil and water conservation planning, we very much require the soil erosion risk assessment of watershed, and that we can generate using remote sensing in GIS. So even the erosion modeling, we can estimate the surface runoff, we can estimate the soil erosion rates, we can estimate the sediment loss, we can estimate the nutrient loss. So at the watershed, how much nutrient we are losing, how much sediments we are losing, what is the erosion rates, these things will be very much can be derived using erosion modeling. So and remote sensing provides a very important variables for these erosion models, which will be discussed on third day of my lecture of geospatial modeling of soil erosion. We can use, once you have prepared the land use plan, then we can map, we can also monitor the development work carried out in the watershed using remote sensing in GIS. Suppose you take the satellite data of one area we have taken in 2010 and the same area we have taken in 2013. These were the agriculture field, and this agriculture field we identified that here there should be one water tank. So water tank was constructed on the ground. You see this water tank, and because of this water tank, where to construct the water tank, this informations were generated based on your terrain characteristics. So terrain characteristics was taken into account, and in land use planning suggested here the watershed tank should be there, and you see that by the irrigation this area becomes a agriculture croplands, but earlier it was the fallow land. So watershed monitoring programs are being done, are being executed in our country using geospatial technology. And the last day of my lecture, special guest lectures will be conducted for how we are using geospatial technology in watershed monitoring. ISRO having a geoportal Bhuvan, where we are keeping this monitoring program, monitoring informations online for the use for the watershed development authority or administrative people. Watershed management, basically what we want to achieve, I can say that is suppose this is the one area which was, you can see that is the here the lands are get degraded, lot of eroded lands are there, top layer is washed out, and you see this is the agricultural land but crops are not there. So by doing the watershed development programs, this area was converted into the green land. So watershed development programs, if you generate the appropriate informations, reliable informations, and integrate and generate other derivatives, then that information can be utilized for planning of the watershed. How we are doing the watershed land use planning? You can say prepare the land use land cover map, soil map, slope map, hydrogeomorphology map, and action. Then by integrating all these maps, you can generate the action plan, where to you can suggest the land use plan. Suppose where to go for agroforestry, where to go for agro-horticulture, where to go for intensive agriculture, that or where to go for double agriculture, double crop agriculture land. So these things can be suggested by analyzing these informations, and remote sensing give you a very vital tool for generating these informations. So what conservation measures we can suggest? So in one lecture for conservation planning, remote and land use planning and conservation planning, we will see also in the coming lectures that where to suggest what conservation measures. You see that this is the terraced agriculture. You can conserve the slope. Here for water, these are the gully, and gully can be plugged with the stone patching. So here water will be accumulated. But where to do all these things we can identify by using remote sensing data, by analyzing the terrain. Then we can propose where to, what to do, and then we can conserve our soil and water. Thank you very much for joining this lecture, and I hope that you have get some idea about the watershed management program in the country and watershed programs, how the remote sensing and GIS can help in watershed management. And in coming days from tomorrow and onwards, we will go what I covered in this lecture in more detail, so that you can execute or you can learn more about watershed management. Thank you very much. And if you have any questions, then I can take it.